Hello learners, welcome to Topical Revision, Form 4 Physics. We are going to be looking at some topical questions in a topic called Digital Electronics. Your syllabus requires that you should be able to distinguish between semiconductor and the conductors, 2 marks. So a question can come in an exam to say, distinguish between semiconductors and the conductors. Remember that when it comes to giving differences between concepts or terms, you can use their definitions to show the difference between the two. Alright, so let's start by looking at semiconductors. What are semiconductors? Semiconductors are defined as materials whose electrical conductivity lies between that of good conductors and insulators. Alright, so semiconductors lie between good conductors and insulators. Remember, examples of good conductors are metals, and the insulators include plastics and paper and other materials. So semiconductors would lie between these two types of conductors. Alright, so in other words, semiconductors are not very good conductors, are not very poor conductors, but they lie between good conductors and the insulators. There are times when you will be required to give the difference between the two. So I'm saying you can use definitions to give you the difference between the two. On the other hand, conductors are those materials which allow current to flow through them easily. Alright? With free electrons, using free electrons. These are conductors are those materials which allow current to flow through them easily. There are also materials which have free electrons or conducting electrons. Alright, so by stating these two differences, you have yourself 2 marks. So 1 mark for saying semiconductors are materials whose electrical conductivity lies between that of good conductors and the insulators. On the other hand, conductors are those materials which allow current to flow through them. They are basically metals. So you can say that, or you can say materials with free electrons. Whichever the case, you get full marks. So you have 1 mark for each statement. We move on to number 2. Question number 2 is saying, give one example of semiconductor and one example of conductor. Alright? Remember, semiconductors are the group 4 elements. So just by naming group 4 elements, such as silicon and germanium, these two are the 2 examples of semiconductors. But the question is saying, give one example. So make sure you know both of them so that you can give any one of them in an exam when need be. Alright. Conductors, examples of conductors are basically metals. So you can name any metal. You can mention copper, aluminium, zinc, iron, any method will give you a correct response to examples of conductors. All right. So 2 marks. The 2 marks here. The 2 marks here allocated as follows: 1 mark for naming a semiconductor, anyone, and another mark for naming conductor. All right, so that was number 1. We were looking at the difference between semiconductors and conductors. Let's look at number 3. Question number 3 is saying, state the difference between semiconductors and metallic conductors. Okay, so in question number 1, we were looking at semiconductors and conductors. But question number 3 is asking for semiconductors and metallic conductors. All right, so the question number 1 and 3 are basically the same, so we'll not waste time to talk about question number 3, trying to answer this, because it's basically asking for the same thing as number 1. So you can say electrical conductivity of semiconductors lies between that of conductors and insulators, while metallic conductors allow current to flow through them easily since they have mobile electrons. Mobile electrons are also called free electrons. So for giving these 2 points, you already have 2 marks there. So you have 1 mark for correctly mentioning this. 1 mark. All right. I hope we're good to go. Although this one is allocated 1 mark, it should have been 2 marks. All right. Let's move on to question number 4. Question number 4 is saying, state the effect on conductivity of increasing the temperature of a semiconductor. All right. Remember that semiconductors have what is called the valence band and the conduction band separated by a forbidden gap. Okay. Good enough, the forbidden gap is so small that electrons can cross easily from the valence band to the conduction band if the temperature of the material is raised. So the question is asking you to say what will be the effect. So an increase in temperature will increase electrical conductivity of the semiconductor. So alright, so we are saying increase in temperature will increase the electrical conductivity of semiconductors. Why? This is because when the temperature is raised, the electrons gain more energy. So electrons in the valence band will gain more energy. As a matter of fact, this energy is kinetic energy. So because of that gain in energy, they are able to move from the valence band across the forbidden gap to the conduction band. All right, you may wish to explain this using a diagram. Remember, semiconductors have what is called the valence band. This is the valence band. And then between the valence band, immediately after the valence band, there is what is called a forbidden gap. And then at the far end, we have the conduction band. Alright, so for any material at all to conduct, electrons must move from valence band to forbidden gap and then get their way up to the conduction band. Then these electrons will be free to conduct. In the absence of these electrons in the conduction band, the material will not conduct electricity. So when a semiconductor, whether it is silicon or germanium, is heated, the electrons are going to jump to gain energy, enough energy so that they can jump from the valence band through the forbidden gap to the conduction band where they are going to conduct electricity. So we are saying that for that to happen, the effect temperature, rise in temperature will have is that the material, once heated, will cause electrons to gain kinetic energy, Ke. Remember, kinetic energy is associated with increase in speed, velocity, or velocity. So the electrons will gain energy and will be able to jump or to move from the valence band across the forbidden gap to the conduction band, hence increasing conductivity. Great. I hope so far so good. I would like you to go through these questions a number of times so that they become part of you, part and parcel of you. But in case you need a PDF of this, you don't hesitate to request that I should send. I can always send this to you so that you can refer to it and revise at your own pace. Name 2 ways of enhancing the conductivity of semiconductors. Alright, in order to enhance or to increase the conductivity of semiconductors, any of these 2 things can be done. You can either increase the temperature, as we saw in question number 4. Increasing the temperature would provide energy to kinetic energy to electrons so that they will be able to jump or move from the valence band through the forbidden gap to the conduction band so that they conduct. So secondly, you can also increase conductivity of semiconductors by a process called doping. We shall look at what doping is just in a while. Alright, we shall look at what we mean by doping, the process called doping. Alright, number 6, explain the effects of an increase in temperature in the conductivities of metallic conductors. Unlike semiconductors, when you heat metallic conductors such as wires, it will cause the particles in it, in this case the atoms, to vibrate. So this vibration will interfere with the electron flow. Remember that when you heat a conductor, its resistance increases. So the resistance will actually reduce the current flowing through the metal conductor, okay, due to collisions between particles. Therefore, the conductivity is decreased. So when you hit a metal which is in a conducting path, current flowing through it is going to decrease. Why? Because heating will raise the temperature of the wire. As a result, the atoms in it are going to start vibrating. Okay, such vibrations will interfere with electron flow because of increase in electrical resistance. Therefore, conductivity is going to decrease. But when you heat a semiconductor, when a semiconductor is heated, increase in temperature will increase the conductivity of semiconductors. Why? Because increasing the temperature will increase the chances of electrons moving from the valence band to the conduction band. Electrical resistance therefore reduces as the current flows. Due to the flow of electrons and the holes. We'll talk about holes later on, but what you need to take from this is the fact that when you heat a semiconductor, its conductivity increases because the rise in temperature will cause the electrons in the valence band to gain kinetic energy, enough energy so that they can jump the forbidden gap to the conduction band. Therefore, conductivity increases. But this does not happen with metallic conductors such as copper. If you heat the metal, the atoms in it will start vibrating, and the vibrations will interfere with the electron flow due to increase in resistance. Therefore, conductivity is going to decrease when a metallic conductor is heated. All right. For now, I would like us to stop now. When we meet again, we are going to continue looking at the rest of the questions in this topic. It will take us to a process called doping. All right, so you can read in advance your notes on doping. Remember that you can request that I send this to you so that you can, in your own time, go through the document and revise the rest of the questions. You can also request that I send to you similar questions for other topics. My name once again is Mr. Paul Chilola. I would appreciate if you subscribe to the channel so that you don't miss on anything that I upload. Bye bye for now.